Okay, guys, we are going to walk through an example of trying to use the four-step process to construct a confidence interval to estimate a population proportion. So let's see if I can get this situated. There we go. So the example, according to an article in the San Gabriel Valley Tribune, okay, most people are kissing the right way. So in this study, a researcher observed a random sample of 124 couples kissing in various public places and found that 83 out of 124 of the couples tilted their heads to the right. Construct and interpret a 95% confidence interval for the proportion of all adults who tilt their heads to the right when kissing. So a little bit of an interesting topic, but let's go with it. So in our four-step process, we start with the state. What are we going to state? When we refer to our PANIC acronym, the P stands for the parameter. So we need to say what our parameter is. So what do we want to do here? Well, we want to estimate P. And what is P? P is the true proportion. P is the true proportion of couples who tilt their heads to the right when they're kissing at a 95% confidence level. So the true proportion of couples who tilt their heads to the right when kissing at a 95% confidence level. So the important things to include in the state include stating what you're trying to estimate, in this case the parameter, the population proportion, and then context of that, of course, and including the level. And again, the level is always going to be told to you. You don't have to decide that for yourself, at least not in this class. All right, then we come up with our plan. Okay, in your plan, you need to assess your conditions as well as say what method you are going to use, right? What kind of interval are you going to use? So we're going to use a one sample Z interval for P, which stands for population proportion, as long as the conditions are satisfied. And I'm literally going to write that. We'll use a one sample Z interval for P if my conditions are satisfied. Okay? This is very important right here. We'll eventually have a one sample interval for mu, for the mean of the population. In later chapters, we'll have two sample intervals for P. So it's important now to say what method we are using. All right, so let's go through our conditions. So we have three conditions: random, normal, and independent. So the first one, random. We either need to have a randomized experiment, right, random assignment, or we need to have a simple random sample. So it said that the researcher observed a random sample, so that takes care of the random condition. So I'm just going to say that my researcher observed a random sample of couples. So that takes care of the random condition. All right, what else? We need to talk about normal. When you're testing the normal condition for proportions, you need to check n times p and n times 1 minus p. Now, since we don't know the true population proportion, right, that's what we're trying to estimate, we're going to use p hat instead. So I'm going to do n times p hat. So n was my sample size, and they looked at 124 couples. The p hat, my sample proportion, 83 out of 124. So clearly that's 83, and that's greater than or equal to 10. And then I've got to do n times 1 minus p hat. So 124 times, let's see, 124 minus 83 is what, 41? Over 124. So both of those are greater than or equal to 10. So we can assume that it's approximately normal because both of those are greater than or equal to 10. So that takes care of that condition. Next condition that we need is independent. Okay. We need to assume that all of the couples are independent of each other, and we also need to check the 10% condition. So we can say the number of couples in the population is at least, and then I need to do a little bit of math. So 10 times 124, which is 1240. So my 10% condition is satisfied. So check that guy off. Now, if this had been an experiment, I wouldn't need to do my 10% condition. 10% condition is only when I'm sampling. Okay, so that's kind of something that's a little bit different. So we've done our state, we've done our plan. So now we need to actually do some calculations. Here's where we actually figure out our interval. So the formula that we're going to be using is p hat plus or minus my critical value times my standard error. Okay, that's all under the same thing. Now I need to figure out my critical value, right? And this is a 95% confidence interval. So over here, I'm just going to figure out this for 95%. Now if you just memorize it, that's fine. But if you're like, I don't remember how to do that off the top of my head, you can use inverse norm. So if you're like, how do I figure out that? Well, that's my little curve. If 95% is in between, that means, paper keeps slipping. That means that 5% is not in between. So half of 5% is 0.025. So in my calculator for my area, I have a 0.025, mean of 0, standard deviation of 1. And we take the positive value of that, and that gives me 1.96, more or less. Okay? And then from there, we plug that into our formula over here. So my p hat was 83 over 124 plus or minus my critical value, 1.96, I almost forgot it. I've got 83 over 124 times 1 minus 83 over 124. And that's all over, make that nice and big. That's all over n, which is 124. Now, you don't have to use the fraction. You could use the decimal. If you use the decimal, 83 over 124 is approximately 0.669. So you could do 0.669 instead. It doesn't matter which one you do. Really doesn't matter. We mentioned that we should use at least 3 decimal places when we're doing our calculations. That is important. Okay. So if you were to just figure out this part right here, my margin of error, that would be 0.669 plus or minus 0.083. Okay. You don't have to figure out what that is, but if you want to do it step by step, you can. And then from there, you can get your interval. We write our interval with a parenthesis to start, so 0.586 is my lower end of my interval, and 0.752 is the upper end of my interval. Okay. Make sure you can know how to do that in your calculator. So take a second, make sure when you plug this in, you get these two values. So we've done our state, we've done our plan, we've done our do. All that's left is to conclude. All that's left is to conclude. And we've been concluding since the first section. So 3 things to include in the conclude section. You need to talk about the confidence level. You need to mention the interval that you calculated. And then also use the context of the problem. So in this case, we are 95% confident that the interval from (0.586) to 0.752 contains, or you could say captures, that's fine, contains the true proportion of couples who tilt their heads to the right when kissing. Okay. So that is a full problem. Now, that took us a little bit of time, but this 4-step process, the state, plan, do, conclude, we're going to be doing basically from here until the end of the year. All right, the only thing that's going to change is the method that we use and then the formulas therein. But it's basically the exact same thing from here on out. So, you're going to get very, very good at this. Okay, and we're going to do more practice with this. In our next video, we're going to be working backwards to find a sample size if we're given a particular margin of error. So stay tuned for the next video.